All right, we are going to go through this related rates problem. I'm going to go ahead and read this. It's going to seem complicated, but we're going to break it down into each individual part. Now, each part of this problem we've already learned how to do throughout the section. Okay, we've learned how to draw diagrams. We've learned how to take the derivative with respect to different variables. Today we're going to be taking the derivative with respect to t. Okay, so let's start reading the problem. As I go through certain keywords, I'm going to highlight them. You should underline them as well. Okay. So the Carnival cruise ship and the Royal Caribbean cruise ship both are leaving from port in St. Kitts. You guys know what port is? Okay, so like where the cruise ship stop. Okay. The Carnival ship leaves port at 8 a.m. heading north towards Antigua at a speed of 28 knots. That's nautical miles per hour. The Royal Caribbean cruise ship leaves port at 10 a.m. heading west towards Punta Cana at a speed of 13 knots. At what rate is the distance between the two ships increasing at 11 a.m.? Round to the nearest hundredth if necessary. Okay, that's a whole lot of information. What were some of the things that you highlighted?
The times they're leaving at.
The times they're leaving at, yeah, that's exactly, because we're going to use that in order to draw our diagram and figure out the distance they traveled. So let's see. Let's do the Carnival cruise left at 8 a.m. I'm going to color code these. And then the Royal Caribbean left at 10 a.m. Okay. Anything else you guys highlight? The speeds and the direction. So I'm going to keep going with orange. Okay. So Carnival left at 8, heading north at a speed of 28 knots. Okay. And then Royal Caribbean left at 10, heading west at a speed of 13 knots. Okay. Let's start by just trying to draw the diagram, okay? Because when we draw the diagram, we figure out what shape we're dealing with, so we figure out what equation, and then what equation we're going to take the derivative with respect to t of, okay? Why don't you guys try to figure out the diagram on your own, and then compare answers with your neighbors or turn around, okay? Just try to figure out the diagram, what shape are we dealing with?
Would Carolina Herrera please come to door 1? Carolina Herrera, please come to door 1.
All right. Want to compare pictures for a minute? Sure. I feel everyone's got the start.
Same direction.
So everyone's working with a triangle, a right triangle?
Yes.
Okay. All right, let's go ahead and sketch what everyone's got. I liked what Kelly started with. She started with a point right here, and then she labeled it port. Because remember, that's our starting. Oh, sorry, we're heading west, so I gotta get a little extra room. So here's port. I can spell port right, that'd be great. Port. Okay. So what ship headed north?
The Carnival.
The Carnival. So Carnival went north towards Antigua. Okay? Then Royal Caribbean headed west towards Punta Cana. Okay? And you can see my triangle form. My right triangle form. Now I know it's a right triangle because it's due north and due west. So it forms a 90-degree angle. So what I'm going to do is just label my X, Y, and Z. We're going to go over to this part of our graphic organizer, the equation. Anytime we're dealing with a triangle, what equation comes to mind? Pythagorean theorem. And what is Pythagorean's theorem?
X squared
Squared
plus y squared
plus squared is equal to z squared. Now this equation is the equation that we're going to take the derivative with respect to time. I want time because I want to figure out the ending question. Okay, at what rate is the distance between them increasing? Okay, I need everything has to be done with respect to time. Okay, all right, so let's go ahead and start filling in the given information. Okay, all right, now the times and the speeds are going to come into play here. So let's start with Carnival. Carnival leaves at 8, traveling at 28 knots. Okay, my goal is to figure out how far are they at 11 a.m. So how many hours did Carnival travel?
3 hours.
3. So it traveled at 3 hours, going 28 knots per hour. So what's the distance it's traveled?
84?
How'd you get 84?
3 times 28?
Yeah, because it's going 28 miles or knots per hour, so 3 hours later, 28 times 3, it's 84 miles, or 84 knots, sorry. Okay. Now we're going to do the same thing for my Royal Caribbean. Okay. It took off at 10, I needed it at 11, and it's going at 11 knots per hour. So how many miles did it travel?
No. Oh, 13.
13, yep. 13. Now, am I able to figure out Z, my hypotenuse of my right triangle?
Yeah. Just plug in the.
Yeah, just substitute it into the Pythagorean theorem to get Z. Okay, so here I have 84 squared plus 13 squared is equal to Z squared. Okay, go ahead and simplify using the Pythagorean theorem and tell me what Z ends up being. Good, I see a lot of people with the right answers. Okay, what's Z? 85, good. All right, we're gonna go towards the middle part of our graphic organism, the variables and the rate of change. Well, I already know 3 of my variables. I know X, Y, and Z, so let's go ahead and fill those out. Okay, I know X is 84. I know my Y, which is 13, and my Z, okay, which is what we calculated was 85. I'll also have to be able to figure out how fast they're changing, and that's where the speeds come in play. Okay? So I need to find what dx dt is. Okay? Dx dt is how fast x is changing with respect to time. So what do you guys think that is? How fast is x changing?
28?
How'd you get 28, Tyler?
By the knots. I think that's how fast it's going.
Yeah, that's how fast the carnival is going. It's going 28 knots. So 28 would be dx dt. What about dy dt? 13, yeah, because it's going 13 knots per hour. And do I know what dz over dt is?
That's what we're finding.
That's what you're trying to find out. Okay. All right. So we officially finished the top half of our graphic organizer. Let's go ahead and go to the bottom. Now all we do is we take our Pythagorean theorem. Now we're going to take the derivative with respect to time. Okay. Now remember, this is what we've already done before in the chapter. You already know how to do this. This implicit differentiation. Okay. So how do I take the derivative of x squared with respect to time? Take the derivative of x squared. 2x. Now I'm powering down with x's, but taking it with respect to t. dx dt, good. And I'm going to do the same for all the other variables. So plus what? 2y dy over dt is equal to 2z dz over dt. Now the hard part is done. Now we're going to take everything that we've substituted up here and substitute into this equation. Okay. So I have 2. What is my x equal? 84. And what's dx dt equal to? 28, good. Plus 2 times my y is 13. And how fast is y changing? 13. And that's going to equal 2 times my z, which is 85. And I don't know dz over dt. That's my variable that I'm trying to solve for. Okay, so what I want you to do is just algebraically simplify that and solve for dz over dt. Okay, do that now. Round to the nearest hundredth, it says in the direction. Okay, go ahead and do that. Compare your answers with your neighbors. Good. Do not forget your units, because your units are a big part of this. What does dz over dt equal?
29.61.
29.61, do we agree? What are we missing? Nuts. Okay. So let's summarize what we're trying to figure out, okay? What is dz over dt? What does that mean?
That's the rate of change.
The rate of change of z, okay? Z, remember, is the distance between the two ships. So exactly at 11 o'clock, which that's what I calculated for, okay? My ships are increasing at a rate of 29.61 knots. Okay, so that's the distance, so it's nautical miles per hour. That's just the distance they're increasing, okay? Why would that number be positive and not negative? Are they going closer or farther apart?
Farther apart.
Farther apart, so that number has to be increased, and that's why it's going to be positive. Okay, so what I want you to do is kind of summarize your final answer using your dz over dt. Okay, write one complete sentence summarizing what our results were. Why don't you have your partner or the person next to you read your response and see if it's something that's similar to yours. You don't have to switch papers, just lean over if you want. See if it's similar. What do you think? Is it similar?
Yeah.
Looks good.
Looks perfect.
What do we say?
Good job.
What was our final answer?
Said the ships were increasing at a rate of 29.61 knots.
Yeah, that's exactly what all you have to do is summarize your results, right? Now, how difficult would this problem be if we didn't have it breaking up into the individual parts?
Very good.
Yeah. Is it overwhelming in the beginning?
Yeah.
Yeah. Okay. So we basically took everything that we learned in the entire chapter, all of Unit 2, broke it up into individual parts to be able to solve this problem. Okay? Good job. All right.